All right, this is Lecture 4 in Informatics 43, and we are continuing to answer the questions that we started talking about last time. How do we know what to build? Last time we talked about requirements engineering, and I introduced that by showing you some examples of software failures, situations in which the software process and software development had gone really wrong. And we discussed that a lot of these failures can be directly attributed to requirements problems, not doing requirements correctly or enough requirements. And so doing requirements correctly is essential. And part of how we do this is by creating a requirement specification. A requirement specification should define the what, not the how, and it's really important to do it correctly and thoroughly because it serves as the basis for all future development. And by actually putting in the time and the effort and the rigor and formality early on to make sure that you understand what the software should do, you end up saving money when you don't have to make lots of changes later on after you've created a lot of artifacts and you're really far in development. And we also talked about one specific structure for a requirement specification. This lecture continues on the question of how do we know what to build. We're going to talk about use cases, and use cases are another way to specify requirements. So they go hand in hand with requirements. The activity of creating use case diagrams and models will help you to analyze the requirements, figure out what they are, and to get them down in a documented form. So this is a 3-part video lecture, and this part 1, will talk about that first bullet, what and why, what use cases are and why we use them. And then part 2 will talk about how we come up with use cases, and part 3 will talk about use case diagrams. So we're going to talk about what and why use cases. First of all, what is a use case? Well, the definition is a textual description of a set of actions defining interactions between an actor and the system that you're developing to achieve a goal. So a lot of times when you talk about use cases, people immediately think of a diagram. So a use case specifically is not actually a diagram. There are use case diagrams, but a use case itself is a textual description. So, and so each use case is about a goal that an actor will have with a system. So some of the goals might be like creating a login or printing a file or changing the font or registering for an account. So some kind of goal, that measurable goal that a user might have or some kind of actor might have with the system. A use case will include these things, some basic functionality goal like I just mentioned, any kind of precondition like maybe the user has to be logged in ahead of time or they have to have something installed, anything that's necessary for them to complete that use case. And then a complete and meaningful flow of events, sort of like the interchange or exchange of data between the actor and the system to accomplish that goal. And a post condition, this kind of captures the contract or the guarantees that will hold at the conclusion of the use case. And then use cases should also always specify any kind of error conditions, what happens if something goes wrong, or alternate ways to accomplish the same goal. And like I said, use cases go hand in hand with requirements. They can be used to express requirements. They're usually used in conjunction with requirements documents. So I mentioned that use cases have a flow, right? They have multiple flows. A flow is just a sequence of steps that describe an interaction between a user and a system. So each flow corresponds to some single path through a use case. And the use case itself usually has one or more flows that each one is one way to accomplish a specific user goal. For the most part, we can have exception flows, which we'll get to later. So for example, for an ATM system, we might have one flow that goes like this. Flow 1 is you enter the PIN successfully, and you put in your card, you enter the PIN successfully, and you get your money out of the ATM. A different flow might be you enter the PIN incorrectly, and so you get kicked out of the system. A third flow might be you enter your PIN incorrectly 3 times, and then you're locked out of the system for the rest of that day or something like that. So what I just described to you are different kinds of flows. A basic flow, so there's always going to be a basic flow for any use case. And this is what we call the happy day scenario. The basic flow is just the typical way that this goal will be accomplished. For example, if we're talking about Amazon and we have a use case called buy a product, the basic flow might be something like this. The customer browses the catalog, adds their items to their shopping cart, and then when they want to pay, they put in their shipping and credit card information, and the sale is confirmed. They get an email, order is complete. That's one flow, but we can also have other flows. So, like I said, there's always a basic flow, but sometimes we have alternative and or exception flows. So an alternative flow is just the goal being achieved, but in some kind of an alternate way. For example, in the flow I just mentioned for buy a product, one alternative flow might be that that the system uses saved credit card information or saved shipping information to also accomplish that. So it kind of skips over that part of basic flow of entering that information. And then an exception flow is a flow in which the goal is not achieved. So it's some kind of error condition. For example, a credit card is declined, or the shipping address entered is an invalid address. So a use case should capture all the possible flows, whether they're successful, like the basic and alternative flows, or unsuccessful. So again, a use case can consist of multiple flows. So why do we use use cases? Why can't we just use a requirements document? Or why can't we just use use cases and not requirements specifications? Well, they're each kind of good at different things. And this shows you here in this table some strengths of each and some weaknesses of each. So when you have a requirements document, which is the column on the left, that doesn't necessarily, a big chunk of text does not necessarily map really well to design or code. But when you have use cases, it's really kind of, the flow is spelled out in a sort of an algorithmic way that can be easily translatable to code. And also the use cases themselves can be mapped to design constructs like UML classes and things like that. Also, requirements engineering methods, because they're not specified in this really operational, user-oriented, goal-oriented way, it sometimes can be a little difficult to translate them into acceptance tests. But because use cases specify the interaction between the actor and the system, well, you can easily kind of just translate that directly into an acceptance test script and follow those steps. And then if indeed the system does work as the use case specifies, well, then the test has passed. Also, use cases are really good for stakeholders of all kinds of backgrounds, even non-technical backgrounds, to understand because, again, it's in terms of user requests and system responses, and that is pretty much understandable for anybody who knows how to use a computer, whereas a requirement specification might be a little bit too technical for non-experts to understand. So use cases are really useful for those kinds of things, but they're not good for everything. So some examples of things that they're not useful for is, first of all, specifying user interfaces. That would really kind of be more appropriate for a mock-up, some kind of drawing of the user interface or prototype, but you can't show that in a use case. It also is not good for specifying data formats. If you want to specify, like for Amazon, what kind of data you want to hold for a customer, like a customer consists of a name, an address, an email, a login, an order history, those kinds of things, you can't specify that using a use case. Similarly, it's hard to specify business rules with the use case. So for example, a business rule for Amazon might be what defines a Prime membership, what defines a student membership, and any other kinds of memberships they have. Or you might have a payroll system that should automatically know that after an employee is in the system for 3 months, they become permanent and they get their benefits. So use cases wouldn't be appropriate for specifying that. And then non-functional requirements. These are the software qualities like scalability, usability, maintainability. There's really not a good way to put those in use case format either. And so we still need these other requirements engineering methods. And mainly in this class, we'll just focus on requirement specification that we talked about in the last lecture. So one of the fundamental components of a use case is an actor. I've mentioned the word actor several times. So what is an actor? Well, an actor is any kind of external entity that interacts with the system. So by external, that means that an actor is not part of the system. It lies outside the system. And an actor can be either human, like a user, or some piece of hardware that the system interacts with, like maybe a sensor, or some kind of like, I don't know, a printer or something, or another software system. So these are all things that are not part of the software. And by hardware, I'm not talking about like the hardware that the system is running on. Like it's not going to, if you're building an iOS app, the iPhone is not going to be an actor. But the GPS in the iPhone might be, or the camera in the iPhone might be, as well as the camera software. So there's always, in every use case, there's a primary actor, and this is the one that has the goal that the use case is trying to achieve. So there can also be additional secondary actors that are just involved in the use case and not necessarily the ones initiating it. Like if you are using some kind of a navigation app and one of the actors is the phone's GPS, well, the user is going to be the primary actor because they would initiate the use case of like find shortest path to location X. But the GPS would also be involved as a secondary actor because it has to interact with the system in order to accomplish that goal. And so you can think of a use case as a dialogue between actors in the system in which they actively interchange some kind of information in order to accomplish that goal. And we'll talk about use case diagrams a little bit later on, but when you create a use case diagram, an actor is always represented by a stick figure, like this one shown below. How do we identify actors? Well, we can very simply, when we start analyzing use cases, we usually have some kind of documents describing the system, whether it's a partial requirements document or some kind of outline. So we want to read those and figure out who are the people involved, what's the hardware involved, what are the interacting software systems. And we can also talk with customers and domain experts and try to figure that out through them. Here are some useful questions for identifying actors. The questions to find human actors would be like who uses, installs, starts up, shutdowns the system, and then what other devices, hardware, external systems, hardware, and or software work directly with the system. And then finally, here's more questions for identifying actors, just helping you to brainstorm some different actors that there may be. For example, does the system use an external resource? So if you think about like travel systems like Orbitz or Travelocity, those kinds of systems are built around external resources. So like, also things like insurance quoting services where you ask for a quote and their system goes and pulls data from all these different insurance companies and presents it to you. So using an external resource, this is very very commonly done. If you have any kind of a system that requires a payment, it's probably going to use some kind of external payment processing system, like a credit card processing system or PayPal or Stripe. Also for authentication, if you think about any kind of application at UCI like Canvas, well, it uses UCI WebAuth to get authentication before you can log in to Canvas. And then a lot of times things will be built on legacy systems that are still in place. Legacy systems are just old, some old system that's outdated, but sometimes they keep them around for various reasons, like it's holding critical data, it still works, but you have a new system sitting on top of it. So sometimes a legacy system will be an actor. Okay, now it's your turn. This is a little assignment for you to brainstorm some actors for the to-do list app. So use those questions and think about what might be some actors involved in to-do list. And write these down, bring them to lecture on Thursday. We'll be using this in class.